So the remainder theorem is this interesting little shortcut, really. What I want to show you, and it's quicker than actually doing it on a computer most of the time. So what it's asking for is to evaluate this whole polynomial at 6. So they want you to stick 6 in right there, stick 6 in at the A, stick 6 in there, stick 6, and add it all up and see what we got. So that's what they want us to find. I want to just sit back and watch for a second. I want to show you a couple things, a couple options that we have in order to solve that. And one of them is to put all that stuff in your calculator. So I'm going to go ahead, instead of it as an A, I'm going to type it in as an X. I'm going to go 2x to the 4th. Let's clear all that. 2x to the 4th minus 18x to the 3rd plus 41x squared minus 29x minus 12. Now I'm going to go ahead and say, I'm going to graph it on the standard grid, so I'm going to say graph 6 on a 10 by 10. I really don't have any idea where that's going to be. Okay, there's a little bit of it. Now it doesn't matter. What I have to do is have 6 be on the screen. So it's going from -10 to +10. So 6 is 1, 2, 3, 4, 5, 6 is right about there. So once I have that, I can do second calculate a value when x is 6. And it'll plug 6 in there and put the bug right at 6. And as we can see, when x is 6, the answer is -6. Okay, so that's one way to do it. Another way to do it is, notice I put that in this y equals button. On the calculator, there's this variables key. That stands for variables. Okay, I put it in variable y1. y1 has this entire formula in it. Okay, I can access that entire formula by going under variables. I'm going to hit variables. I'm going to go over to y variables, and it's in a function. y1 is a function, so I'm going to hit enter on function, and there's y1. That puts y1 on the screen, and if you put parentheses 6, that will take the number 6 and plug it into the formula that's in y1, and there's the -6 again. Now this is a nice function if you want to get several, like if I also needed to know what is it at 10, it'll take 10 and stick it in that formula, and it's 5,000 something. And if I wanted to, and if I wanted to maybe see what it would be at just 1, I could stick 1 into that thing, and it's at -16 and so on. So that's another good way. So you can plug it in the grapher, graph it, and calculate the value. Or you can put it in the graph, the y1, and go to vars and evaluate it at y1. None of those are the remainder theorem. Here's what the remainder theorem says. You also can do this. I'm going to write down all of these coefficients without the letter x. So it's 2, -18, whoa. Let's try that again. 2, -18, 41, -29, and -12. I'm going to put this little box over here and plug in the 6. Okay, here's how the remainder theorem works. I'm going to draw a line. First thing you do is drop down the 2. Now, this 6 gets multiplied by that 2 and goes up there. So this is the multiplying thing. So 6 times 2 is 12. So first you drop down the first one, then you multiply over. Then you add down. So -18 plus 12 is -6. Then I multiply over again. So 6 times -6 is -36. Then I add down. That's what the remainder theorem does. It multiplies across, adds down. So 41 plus -36 is 5. Multiply across, 6 times 5 is 30. Add down is 1. 6 times 1 is 6. And -12 plus 6 gives us a remainder of -6. It ends up giving us what the answer is if we took the 6 and stuck it in all of those A spots. Now that's pretty cool. So I'm going to do that with number 2. The thing you have to worry about is you can't have any exponents missing. It's got to go power 5, 4, 3, 2, 1, 0. And if one of them is missing, we just put a 0 in that spot. Okay, so none of them are missing here. So I've got 2, 10, 14, 26, 4, negative 23, and I would like to plug in a negative 4. Okay, we draw a line. You start out by dropping in the 2. Then you multiply across. Negative 4 times 2 is negative 8. Add down is 2. Multiply across. Negative 4 times 2 is negative 8 again. Add down 14 plus negative 8 is 6. Multiply across. Negative 4 times 6 is negative 24. Add down is 2. Negative 4 times 2 is negative 8. Add down is negative 4. And negative 4 times negative 4 is 16. When I add that down, 16, negative 23 plus 16 is negative 7. Negative 7 is what this evaluates to if you plug in a negative 4. Now this last one, I actually want to pretend, I'm going to change the problem just a little bit. Let's say this one was not there. So it goes a to the 4th, then an a to the 2nd, then an a. Okay, you can't have that. A to the 4th is a 1. The a to the 3rd term has to be in there. You have to give it a placeholder, so I'll call that a 0. And then a negative 7 for the a second, and then a negative 30 for the a, and a minus 2 for the constant, and plug in a 6. You drop in the 1. 6 times 1 is 6. Add is 6. 6 times 6 is 36. Now when I add that down, that gives what, 29? Okay, I got to go 6 times 29. 6 times 29 is 174. Add down puts it at 144. Multiplied by 6 is 864. Add down is 862. If I take this 6 and plug it into the a to the 4th, a to the 2nd, and the a spot, it's 862. Okay, we can use that idea to find factors. Here's really what the remainder theorem is for. Here's one of the factors. Now, one of the things that we know is this has to have 4 zeros. That means if this factors, it will factor 1, 2, 3, 4 times. Well, we have to find 2 of them, and then we can use the quadratic formula for the other ones. Okay, well, here's one of them. Now, there's a conjugate theorem that if you have imaginary numbers, if this is one of the roots, then negative 1 minus 4i is another one of them. So there's 2 of the factors. There's 2 of the things that end up making that 0. Okay. So when it says 1 root, that means one of the zeros. That means if I plug a negative 1 plus 4i into this, it will give me 0. Now, I actually am going to prove that. Let me type in here's the calculator again, negative 1 plus 4i. Now, I don't know if I ever showed you this, but your TI could do imaginary numbers. I think maybe I did. Okay, so there's negative 1 plus 4. I'm going to store that in a, just so I don't have to keep typing it in a whole bunch. So I'm going to say this one to the 4th. So I'm going to say a to the 4th. So I put negative 1 plus 4 to the 4th, and then I'll type in minus 6 a to the 3rd, so there's that piece, and plus 16a squared. There's that piece, minus 106a, and then plus 255. That should all add up to 0. Okay, why does that not add up to 0? It says that it's a 0 right here. Negative 1 plus, did I not type it in right? Oh, yeah, I didn't type it in right. I didn't put the 6 in front of that. So it was supposed to be minus 6a. So let me get that back and go up here. There should be a 6 right there. Okay, hopefully that adds up to 0. Okay, sure enough, adds up to 0. So what that's saying is if you take this and plug it in for the x, 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 and x, it all adds up to 0. Okay, well, so does this one. But there's 4 of them. There's always the highest degree amount of them. Okay. Well, we could put all this in the computer again and find the zeros like we've been doing before. I could go to y equals and put in x to the fourth minus 6x to the third plus 16x squared minus 106x plus 255 and graph it. And then like we did on one of those other ones, notice 2 of them are imaginary and 2 of them are real. Well, gosh, right there they are. There's the 2 real ones. We could go second calculate, find the 0, go to the left, so I'll put in a 1, go to the right, 1, 2, 3, it looks like 4 will be to the right, and one of the zeros is 3. And then I could go for the next one, second calculate 0, left at 4, right at something like 6, so it'll search between there and it'll find that one. Looks like it's going to be 5 and 5. So the other 2, so I already know from the calculator that the other one is 5 and the other one is 3. So there's the 4 zeros, 2 imaginaries and 2 reals. Okay, but we want to use the remainder theorem to do that. So here's how you do the remainder theorem. Okay, let's go 1, negative 6, 16, negative 106, and 2, 55. Okay, if this is a 0, if I plug all of this in there, which I did on the calculator, it should end up having a remainder of 0. So I'm going to do that. Negative 1 plus 4i. Okay, here's how the whole thing works. Drop down the 1. Take this times 1. Well, all of this times 1 is negative 1 plus 4i. Okay, now I'm going to add. Well, only the real parts add together. So when I add this down, it's negative 6 plus negative 1, so negative 7 plus 4i. Okay, now I've got to multiply those two together. Now, I could go do that if this was a non-calculator one, I'd go to the side and I would actually, okay, I think I'll model that. I'll go to the side and multiply that together. Negative 1 plus 4i times negative 7 plus 4i. Let's see what that is. Negative 1 times negative 7 is 7. Negative 1 times that is negative 4i. 4i minus 7 would be times negative 7 is negative 28i. And 4i times 4i is 16i squared, but i squared is a negative. So it ends up being negative 16 plus 7, so negative 9 minus 32i. So when I take this one times this one, it ends up being negative 9 minus 32i. Now, if you have a calculator, you can go ahead and do that on the calculator. I could have just said negative 1 plus 4i times negative 7 plus 4i. And there's the negative 9 minus 32i. Okay, so now I'm going to add this down. So 16 plus negative 9, so that will be 7 minus 32i. And now I've got to take this one times this one and multiply it into the next spot. So I'm definitely going to use the calculator for that. So I'll go negative 1 plus 4i times 7 minus 32i. It's 121 plus 60i. Okay, so this is 121 plus 60i. Okay, add down. So the negative 106 and the 121 is going to end up being 121 minus 106 is 15. So that ends up being 15 plus 60i. Okay, I'm going to multiply this one times this one and put it up here. Now, it better be negative 255 or else this didn't end up being 0. I'm going to make sure that's the case. So on my calculator, negative 1 plus 4i times 15 plus 60i. Sure enough, negative 255. So that adds up to negative 255, remainder 0. Okay, that's step 1. So that's telling us that this is a 0. Now notice this was to the 4th, to the 3rd, to the 2nd, to the 1st, and then no power. Okay, I've taken out 1 0. 1 0 has been removed, so 1 power has been removed. These answers here, now this is like the third power, the second power, the first power, the constant. So I'm just going to leave that there and find the other 0, which I know is this one right here, -1 minus 4i. And do it again. Okay, I'm going to drop down the 1. 1 times this is -1 minus 4i. Okay, when I add that, look, the 4i's go away, and it's just going to be -8. So now I'm going to multiply across again. So -8 times -1 would be 8, and -8 times -4 will be plus 32i. Okay, look, when I add this down, the i's go away again, and I'm just left with 15. Okay, now I'm going to multiply these. 15 times that. So 15 times -1 is -15, and 15 times -4i is -60i. And 15 minus 15 is 0, and 60 minus 60 is 0. Have no remainder. These two are confirming that those two were zeros. Okay, now, this was an x to the 4th. We removed 1, made it x to the 3rd. This was x to the 3rd. We found a 0, made this x to the 2nd. What this means is it's 1x to the 2nd minus 8x plus 15 equals 0. Okay, well that will factor. That factors to x minus 5 and x minus 3. That's -5 and that's -3 for -8 makes the middle. 5 times 3 is 15. So now the zeros, what makes this piece 0 is the 5, which is that one. And what makes this piece 0 is the 3, which is that one. So we're able to find the zeros. We took the 2 zeros that they gave us out of it, got it down to the quadratic formula or factoring, and then that's why we want to have a whole bunch of ways to get this, because if we can get to a square, we can either use the quadratic formula or factor it. Okay, let's try that a couple more times. Here's number 5. Okay, here is an imaginary number. If that's one of the zeros, then 1 minus I is another 0. So we found one of them already, just because we know that conjugates are always zeros. So there's going to be 4 of them. We just found 2 of them, so there's 2 more. The way we find the other 2 is we take these 2 out. That'll get it down. If there's 4, we remove 2. That'll get down to a square. And once we get it down to a square, we can use the quadratic formula. Okay, so I've got 1, -6, 13, -14, and 6. And I want to plug in 1 plus I. That's one of the zeros. That should have a remainder of 0. Okay, here's how it starts. You drop in the 1. 1 times that is 1 plus I. Add down. -6 plus 1 is -5 plus I. Okay, I'm going to use my calculator assist, so I need to take 1 plus I times -5 plus I. So 1 plus I times -5 plus I. So I typed that in my calculator right there. Is -6 minus 4i. So this multiplies to -6 minus 4i. Add down. So it's the 13 minus 6 will be 7 minus 4i. Okay, got to take this one times this one and put that up there. So again, I'll do that on my calculator. So it's going to be 1 plus I times 7 minus 4i. So I typed that in my calculator. 1 plus I times 7 minus 4i is 11 plus 3i. Okay, add that down. It's -3 plus 3i. And one more. Now I got to multiply those together. 1 plus I times -3 plus I. I mean -3 plus 3i. Okay, so I type that in my calculator. It gives us -6. And that adds up to 0. Okay, so yes, that is a 0. There's confirmation. Now, out of this remainder stuff, I'm going to put in the other 0. 1 minus I. And do it again. Okay, drop down the 1. 1 times that is 1 minus I. Well, now the i's go away, so it's really -5 plus 1 is -4. Okay, multiplying this one. Negative 4 times 1 is negative 4. Negative 4 times negative I is plus 4I. And look, the imaginary part goes away again. So 7 minus 4 is 3. And now 3 times 1 is 3. 3 times negative I is negative 3I. And look, the real part, negative 3 plus 3 is 0. And the imaginary part is 0. That confirms that this one is also a 0. Now, it started out as a fourth. We took out one, left a third. The third, we took out one. This is a second. What this means is 1x squared minus 4x plus 3 equals 0. Okay, well, I can either use the quadratic formula or I can factor it. Now, I would really like to use the this one factors easily enough. Let's see. How about x times x is x? The only choice for 3 is 3 times 1, and if I make them both negative, negative 3 times negative 1 is still positive 3, and there's negative 3 inners and negative 1 outers adds up to negative 4. So this one makes a 0 of 3, and this one makes a 0 of 1. So this graph had two imaginary zeros, and then it crossed the x-axis at 3 and 1. Okay, square roots do the same thing. If we have a square root, that means 4 minus the square root of 33 is also one of the answers. So we already know conjugates are always zeros. If you know one of the zeros, you know its conjugate is another 0. So just by knowing that gets us started. Okay, so applying the rational root theorem, I've got a 3, a negative 22, a negative 72, a 6, and an 85, and I'm going to plug in one of those zeros. I'll just plug in the one they gave us, the 4 plus root 33. Okay, first things first, drop in the 3. Okay, 3 times all of that, 3 times 4 will be 12 plus 3 roots 33. Okay, well, negative 22 plus 12, so it'll be negative 10 plus 3 roots 33. Okay, now this is going to be a little bit tougher because I've got to multiply it up there, and the TI-83s, TI-84s don't do roots quite as well. The little mini calculators that the school has does those roots pretty well, actually really well. Okay, let's see here. I think I'll just come up here to the side. 4 plus root 33 times negative 10 plus root 33. 3 roots 33. Okay, 4 times negative 10 is negative 40. 4 times 3 is negative 12 roots 33. Negative 10 times 3 is negative 10 roots 33. And root 33 times root 33 is 33 times that 3 is 99. So this one times this one multiplies together to what, 61, negative 99 minus 40. No, 59. And then negative 12 minus 10, so it's 59 minus 22 roots of 33. And add down. So I've got 59 minus 72, so I've got negative 13 minus 22 roots of 33. Now I have to multiply it times this one again. Okay, I think I'm going to use my calculator now for that. So let's see if we can't help ourselves go a little bit faster. So in parentheses, I'm going to go 4 plus root 33 times, and then I want negative 13 minus 22 roots 33. So negative 13 minus 22 roots of 33. Now the calculator is going to give that to me as a decimal. I don't really like it as a decimal, but it's going to be it's going to be a decimal. But I need all of that decimal, so I'm going to store that in A, so I don't lose any of that. It's the difference between doing it exactly and the calculator has to round that a little bit. Okay, but I'm going to store it in A so the calculator can handle it as much as possible. So it's right around negative 1358. So that's an estimation, but I have it on my calculator. Okay, I'm going to add 6 to that. So on my calculator, add 6 is negative 1352-ish. Now I need to take this one times this one. Well, I know it has to be negative 85 or else that wasn't a 0. But let's just check. So there's the A number, and I need to multiply that times 4 plus the square root of 33. I'm really expecting that to be negative 85. Okay, it is not. Something went haywire. Let's see, where did I make a mistake? Let me go back all the way back here to the beginning. I think I'll go back and do it as decimals from the beginning. I probably don't need, this one is right. 4 times, that's 12, and 3 roots 33. Adding that together. So probably I mismultiplied right here. Let me get that one. So 4 plus the square root of 33. This is what you have to do. So this is why knowing that that had to be negative 85 helps. So 4 plus roots 33 times negative 10, 3 33s. Let's see what that is. Okay, that's about 70. So I'm going to just throw this thing out right here as about 70. Now, it's 70 with a bunch of decimals, so I'm going to store that one in B. So I know this one's in B. So 72 minus B is about 1. So this number right here is right around 1. So I need that times 4 plus root 30. So I need this 1-ish times 4 plus root 33. So there it is still on my calculator, times 4 plus root 33. That was about 14. So this one times this one right up in here was about 14. So I need 6 plus that. Okay, so there's the 14. I'm just going to add 6. That's 20. So this piece right here was about 20-ish. Now I need to take that 20 times 4 plus root 33, and that better be negative 85, times 4 plus square root of 33. Wow, it's not 85 again. Okay, what the heck? I'm gonna have to start this one all over. I obviously have a mistake someplace from the very beginning. All right, sorry about all of that. Let's do it again. This is what happens when you, sometimes this happens to kids also. So let me start this one over fresh and really try to be careful. So I've got a 3, I've got a negative 22, I've got a negative 72, got a 6, and we have an 85. And we want to plug in 4 plus square root of 33 because that is supposed to be 0. Okay, drop in the 3. Okay, here's another trick. I'm going to take this 4 plus the square root of 33 since it has to type in all the time. 4 plus the square root of 33. And I'm going to store that in X just so I don't have to type it every time. Every time I need that 4 plus square root of 33, I'll just type in X. So there it is. It's about 9. Okay, so I need this. This is approximately 9. So basically I need 9 times 3 to put up here. Okay, so I'm going to take 3 times X on my calculator. That's about 29. Then I need to add down, so I need to add negative 22. So from that 29, I'm going to subtract 22. That's about 7. Now I need 7 times that X number. So I'm going to take that times 7. So I'm going to say answer times X. That's about 70. So this number up here is about 70. Add that down. So now I'm going to add a negative 72. So minus 72 from that is negative 1.5. I need to take that negative 1.5 times the X. So I'm going to say times X. That's about negative 14. Need to take that negative 14 and add 6. That's about negative 8. Now I need to take that negative 8 times this x again, and I sure hope this time it's negative 85 times x. Yay, negative 85. Remainder 0. Okay, so that took a little bit of work. Now we want to practice the remainder theorem, so go through the steps with that. Okay, here, now I want to do 4 minus the root 33, because I'm trying to get down to the quadratic formula so I can find the last 2. Okay, so I'm going to do the same strategy. I'll start out with the 3. I'm going to put 4 minus root 33 into x this time on my calculator. So I got 4 minus the square root of 33. I'm going to store that in x. So it's about negative 1.7. Okay, first I need to multiply it times 3. So I'll take that answer times 3 is about negative 5. I'm going to add 7. Okay, so add 7 to that is about 1.7. I need to take that 1.7 times this x number. So I'm going to go times x. Let's take 1.7 times x is about negative 308. Now I'm going to add the negative 1.5. So if that negative 308 plus negative 1.5. Uh-oh, this isn't going to do it, is it? These are all rounded spots right there. Good grief, I'm going to have to start this one over. Okay, I need a new piece of paper. Well, I guess you're getting to see where mistakes are made on these all the time. It wasn't really my intention, but that's what seems to have happened. So, let's do that one again. I have to store those values so I have them all exactly. I'm searching for some graph paper here, or some scratch paper. If you're not sure why I am bailing on this one to start over again, I'll show you right now. Okay. Goodness. So we have 3, negative 22, negative 72, 6, and 85. Okay, I can't even really use what I had before because I have to store those numbers. One of the given zeros was 4 plus root 33. Okay, we used our calculator, so I'm still going to do that. I'm going to take the 4 plus root 33 and store it in x. Okay. So to get started with, I'm going to drop down the 3. I need to do 3 times that x value. Okay, so there's the x value times 3. So far, so good. It's about 29. So I'm never going to use that 29 again, so I don't really care. I'm going to go ahead and add negative 22. So from that 29, I'll subtract 22. It's about 7. Okay. See, later on, I'm going to use that 7 again. So I actually need to know exactly what that is. That's not 7. It's 7.23, whatever, whatever, whatever. Okay. Well, that means I need to store it. So I'm going to store that one in A. And I'm going to tell myself, okay, this one is in A. The exact value is in A. Now I need to take that 7 times, or that A number, times the X number. Okay, so I'm going to take A times X. That gives me about 70. I'm going to add down the negative 72. Okay, same thing. I need all of that number for the next part of the problem, negative 1.5. So it's about negative 1.5, but I'm going to store that one in B, and I'm going to tell myself where it is. So I'm going to store in B. Now to get up here, I need B times X. Okay, so I'm going to say B times X. B times X is negative 14-ish. And then I'll add 6 to that to get down there. So I'll add 6. Gives me about negative 8.7. But I need that exactly later on, so I'm going to store that one in C. And you see how I'm keeping track of what that is? And now C times X had better be negative 85. And it is. Okay, so we got the first 0 to work. Now the next one, see, this is how come I needed these values exactly. The next one is 4 minus root 33. Okay, so this time I'm going to put 4 minus the square root of 33 into x. Okay, so first I'll drop down the 3, I need 3 times x. So first I need 3x, 3 times x is about negative 5. Okay, now I need to add a to that. So negative 5, it's about 7, but it's exactly a. So I need to add a to that negative 5. And it's 2. Okay, now I need to take 2 times this x value. So 2 times x is about negative 3. And I need to add to that this negative 1.5. So I need to add to that the b. So I'm going to add b. Negative 5. Now I'm expecting negative 5 times x to be exactly this. So I need to take negative 5 times x. Negative 5 times x is 8.7-ish. And if I add c to that, I'm expecting 0. And that's 1 times 10 to the negative 11th, so that certainly rounds to 0. That's 0.00000. That's the calculator's way of saying 0 for that. When you're doing square roots, sometimes it has to round to 0. Okay, finally we got the first 2 done. And the first two givens ended up being 0. So this was to the 4th power, this is to the 3rd power, this is to the 2nd power. So I've got 3x squared plus 2x minus 5 equals 0. Now, I'm gonna show you another great trick. It's time that you go get a TI-83. Everybody, you need one. It's time that we even need one in Algebra 2, but you definitely have to have one next year anyway, and they have them for sale at the Student Center. You need to get one of these for yourself so that you can start storing some of these problems. Here's what I'm going to have everybody do. I'm going to teach you some programming right now. So here's the quadratic formula. Okay, so that probably factors, but I want something faster than factoring, especially since I have my own calculator. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, these are variables in our calculator. I mean, I was just storing things in a's and b's and c's. I want to write a program that I can just type in the 3, the 2, and the negative 5, and it just tells me both of these answers. Okay, well, here's how the program works. What I need to do is I need the user, so me, has to put in the values into memory. Okay, so your calculator, that's the first task. Your calculator has a memory chip in the back. It's kind of like mailboxes, and it labels that one A and that one B and C and D and E and F and G all the way to Z. What I would like to do is to put a 3 in the A location, and I would like to be able to type a 2 into the B location, and I would like to be able to type a negative 5 into the C location. So I want myself to be able to put the numbers A, B, and C into these memory slots. And then I would like the computer to calculate the quadratic formula. Well, all that would be is it's going to take the negative b location and add the square root of the b location minus 4 times the a location times the c location, and then divide all of that by 2 times the a location. Now, computers, programs, you have to write the formula flat. So when we say divide, then we got to make it divide by the package 2a. So 2a has to go in its own little formula. So I want to take all of that and store, maybe I put that answer in D. So this will be answer 1. And maybe E can be answer 2. So this will get me the positive answer. So then I want the formula, the calculator to do B minus B squared minus 4AC divided by the group 2A. And put that one in E. So I want the calculator to let me put in the numbers in spots A, B, and C. Then I want it to figure out the first answer of the quadratic formula and then the second answer of the quadratic formula and put that in D and E. And then I want it to show me on the screen. Okay, here's how we write that. This piece right here, there's a code word called input. So right here, what's going to match up with that is the word, well, actually it's called prompt. Prompt A. Prompt opens up the memory of your machine and allows the user to type in a 3. Okay, then I need to open up the memory of the machine and allow the user to put in the B number, the 2, in spot B. And then I need to prompt and put the C number in there. So I need to open up memory slots A, B, and C so the user can type them in. Okay, that's going to be 3 lines of code. Then here, I want the calculator to calculate it. Okay, well, we're just going to say negative B plus square root of B squared minus 4AC divided by 2A, and store that in E, just like we did, or store that in D, I guess, just like we did before. It'll calculate the answer and put it in spot D. And then I want negative B minus B squared minus 4AC and divide that by 2A and store that one in E. So now I'm using memory locations A, B, C, D, and E. D and E now have the answers to the quadratic formula. And now I want to show on the screen those answers. That's called display. So the keyword display, I want it to display what's in box D, and I want it to display what's in box E. This is a quick little program that will, if we ever get it down to the quadratic formula, now we can just type in 3, 2, negative 5, and our calculator will do the quadratic formula for us. So when you get your own calculator, you can have that forever, and then every time you need the answers to the quadratic formula, you just push program. Okay, here's how we get it in. Right here is the program button. Okay, I'm going to hit program. I'm going to make a new one. So I'm going to come over to new. Now, it wants me to name it. Okay, I have to do something here because I see that there's already one in here. Let me go fix this just for a second. I need to delete one of them. Let's see. I need to unarchive it first. See, I'm gonna call it quad, and I already have that in there. So I'm gonna go delete quad so I can build it with you right now. So I'm gonna go to memory, delete a program called quad. Okay, don't have quad. All right, so here's what we do to put this program in there. We hit the program button. Okay, we want a new one. Now you have to name it. So I'm gonna name it quad. So see how the blinking A is already going? That means the alpha key is already on because the programmers know you need to spell something here. So I'm gonna call it QUAD on the green letters. Okay, so now I have a program called quad. These lines of code go one at a time. Every colon is a new line. Okay, all of these words are in the program button now. So I'm going to hit the program button and go over to prompt. See, there's prompt. Oops, not input. Program over one prompt. A. That will open up mailbox A. Then we do program, go over, prompt, mailbox B. Then we're going to go program, over 1, prompt, mailbox C. That allows the user to put a number in boxes A, B, and C. Okay, so for the fourth line of code, I'm just going to do this. I want negative B plus the square root of B squared minus 4AC. So for these older ones, see, that's the square root of this stuff. Then I want to divide all of that by the package 2A. So there's actually the quadratic formula, and I want to store that in D. So that's the positive answer. Then I want negative B minus the square root of B squared minus 4AC divided by the package 2A, and store that one in E. And now it has it in the memory, and now display is how you show things that are in the memory. So I go to program one more time, go over to IO and down to number 3, display. So I want to display the answer that's in D, and then program, go over, display the answer that's in E.